Welcome to this presentation. Its purpose is to summarize the concepts of simple and compound interest and help you perform calculations involving interest. Interest is the manifestation of the time value of money. There are two types of interest used to represent how money makes money over time. They are simple and compound interest. For simple interest, the amount of interest is based only on the original amount of money, called the principal. Therefore, it is easy to calculate for one or multiple periods of time. Compound interest, on the other hand, includes interest on the principal each time period plus interest on all previous time periods. So, compounding involves interest on top of interest. Simple interest, I, is based only on the principal. It is the product of three numbers: the principal, P, the number of time periods, N, and the interest rate, I, which is expressed in decimal form. So, I equals PNI. The definition of each term is shown here. The interest rate is expressed in decimal form when used in the relation. For example, 8% per year is expressed as 0.08. The same amount of interest is due each time period, regardless of whether it is paid each year or accumulated and paid at the end of N years. As an illustration, assume a person borrows $1,000 today and must repay the principal and interest at 5% per year simple interest after 3 years. What is the total interest and amount to be repaid after these 3 years? The interest per year is 1,000 times 0.05, or $50. Over the 3 years, the total interest is I equals PNI, or $150. The repayment is the principal plus all the interest, which totals $1,150. Here's the cash flow diagram. The downward arrow in year 3 indicates the repayment of principal and interest. There is no cash flow in years 1 or 2. Because interest is simple, it is based only on the original principal of $1,000. Therefore, the interest each year is the same, $50, which totals $150 over the 3 years. Now let's consider compound interest. Compute the interest at the end of each period. Let's assume that a time period is a year. Now add this interest to the unpaid balance. This helps determine the interest next year, because the entire unpaid balance earns interest. The formula for compound interest, I, for each year is the principal plus all accrued interest times the interest rate, again expressed in a decimal form. If no intervening payments of interest or principal are made, the total repayment after N years is the principal plus all the accrued interest. As an example of compound interest, assume the same loan of $1,000 with repayment of principal and all accrued interest at the end of 3 years. Now let the interest be 5%, but compounded annually. What is the interest and total amount due after 3 years? Here are the values for P, N, and I. To get started, we will define I sub T as the interest that is earned and due each year, and capital T sub T as the total repayment that is due each year. For the first year, we calculate the interest due and add this amount to the principal to obtain a total amount due of $1,050. For years T equals 2, the interest is based on this total amount due of $1,050. The interest due at 5% is $52.50. Continuing for the third year in a similar fashion, 5% compound interest indicates that the interest in year 3 is $55.13, and the total amount due after 3 years, T sub 3, will be $1,157.63. Let's graphically compare the results for 5% interest, simple, and 5% interest compounded for these two examples. Here is the cash flow diagram for simple interest. It indicates a total amount due of $1,150. Now for the diagram that uses compound interest. Here the amount due is $1,157.63. As you can see, annual compounding of interest is required an extra $7.63 to be paid in year 3. It is important to understand that the difference between simple and compound interest can increase rapidly if the rate is higher, the amounts are larger, and the time period is longer. For example, if the same $1,000 is borrowed at 5% for 10 years, a longer period of time, than the 3 years we have used previously, the total due is approximately $1,629 for compound interest. For comparison purposes, simple interest over the 10 years has a significantly lower repayment of only $1,500. Here the extension from 3 years to 10 years has made the difference between simple and compound interest increase significantly. For simple, the difference was about $8. However, for compound, the difference as shown on these cash flow diagrams is $129. Here is a second example of compound interest, but it includes more than one loan amount. Assume $1,000 is borrowed today and a second $1,000 is borrowed next year. The total amount plus 5% compound interest is due after 3 years. Here's the cash flow diagram. Repayment will occur in year 3. The interest and total due for year 1 are the same as before. That is $50 for interest and $1,050 as the amount due but not paid at this time. At the end of year 2, the additional loan of $1,000 accumulates interest along with the unpaid balance of $1,050 from year 1. Now the interest is 5% on $2,050. The total due after 2 years is now $2,152.50, which includes the $102.50 of interest. For year 3, there is no additional loan. However, interest is calculated on the unpaid balance of $2,152.50. This amounts to $107.63 for a total due of $22,6013. We can now complete the cash flow diagram with this repayment. An important point to recognize when compounding is that interest is accumulated on each of the $1,000 loan principals, plus all the previously calculated interest. Virtually all computations in engineering economy evaluations rely on compound interest. If simple interest is to be used, it will be specifically stated. You have now completed the presentation on simple and compound interest. Thank you for watching.